Hi guys, in the following video I get the chance to talk to Arjen Markus, the author of Modern Fortran in Practice. He started his career in fluid mechanics, specifically numerical modeling of water quality problems, working for Deltares or when he joined the company Delft Hydraulics. He said that over the years as he became, his work became more about maintaining and developing the software to do those numerical models, he focused more and more on the features of modern Fortran and modern software development practices and applied those to a variety of articles and eventually into his 2012 book. He's also had the opportunity to do PhD research on nanoparticles in the aquatic environment and has always kept an interest in his original area of expertise, combining practical and theoretical subjects, or at least that's his passion, he says. He lives in a suburb of Rotterdam with his wife of almost 30 years. They have 3 kids, 2 daughters and a son, and 1 grandson who's half a year old now. We discussed the problem of allocatable variables versus pointer variables and the features of both and when you might prefer one over the other. So let's dive right into the conversation. Basic idea here is I've been asking around about questions that people have with Fortran, the language, and things they'd like help learning about, that kind of stuff. And one of the very first things is, can you help explain pointer semantics and and why you might use that over allocatable variables? And you piped up and said, hey, I just got a question about this that was related to this, and I would like to help out. So to start off with, let's start with allocatable, because I think that's at least a slightly easier place to start.
It certainly is, yes.
Where basically the idea of an allocatable is I've got a variable that I don't necessarily know the size of the array or possibly the type of the value that I'm going to be storing at runtime at compile time, right? So other static variables are something that you need to know the size of or type of at compile time. And you may have to correct me on this one, but I believe when that allocatable was initially introduced into the language, automatic deallocation upon exit from scope wasn't part of the standard.
That's right. That came with the Fortran 95 standard.
That's what I thought. But with that addition, using allocatable, for the most part, you shouldn't have any memory leaks unless there's a compiler bug of some sort.
Well, actually, if you only have allocatables and no pointers at all, then memory leaks are actually impossible.
Sans compiler bugs.
Yes,
I have found some instances where some allocatable stuff just there was clearly a bug in the compiler, but
yeah. Yes, okay. But theoretically, if your compiler works according to the semantics of the standard, then memory leaks are impossible.
Yep. Okay. So now, then moving on to pointers. Pointers give you the additional capability that the data in the variable can outlive the variable that created it, essentially.
Yes, and in that case, you have a dangling pointer, because if the memory which was allocated at some point, for instance, via an allocatable, and you point to that memory via pointer variable, then the allocatable stuff may disappear, and then you have a pointer which points to something which has disappeared.
Right. Both opportunities for missing.
Yes. Right, yes, that's one opportunity. Of course, you don't have a memory leak then, but you have a reference to memory which is no longer yours.
Correct.
That's one problem. The other problem is you allocate memory via pointer, and later on in the program, you allocate again via that same pointer. then the first memory you had is no longer reachable. And then you have a memory leak.
Right.
And there's nothing you can do about it except for correcting your program.
Right. So thinking about kind of the semantics of allocatables and static variables, basically anytime you cross a procedure boundary, calling a subroutine or a function or returning from, you need a copy in or a copy out, right? According to the semantics of the standard, it's in principle, you're supposed to do a copy in or a copy out. Of course, you know, optimizations and things can find cases where it's not strictly necessary and safe to avoid the copy. But from the kind of principle semantics, you're passing things by value, not necessarily by reference.
Well, Fortran, you essentially pass by reference, or at least that's the most common way to do it. Copy in, copy out is sometimes necessary because your subroutine is in Fortran 77 style, and you pass in an array which is not contiguous. An array section from the second or third dimension, for instance.
Okay.
That's not contiguous memory. So your Fortran 77 routine or styled routine doesn't know about that. The array is declared with an asterisk. And then the compiler knows it has to copy everything into a temporary array and copy it back into the original array. That's one case where you can have copy in, copy out.
Okay.
But essentially, the semantics of the language is such that that's just a mechanism which is used to get correctly working procedures. It is quite possible to do it in another way.
Okay.
But that it really depends on the situation at hand. But the way you how do you call that? How do you say that? Copy in, copy out is not a requirement from the standards.
Okay.
Just like you have that on the right-hand side, everything is evaluated, and then it's copied into the left-hand side of an assignment. Whether it works quite that way is something up to the compiler, but the semantics is such that you have the right-hand side, which is completely evaluated, and then copied over to the left-hand side. That's the semantics. If the compiler can find a smarter way to do that, then it is certainly allowed to do that.
Okay.
That's part of the system. What it does mean is that it has to, for instance, the right hand side is a double precision, and the left hand side is single precision. The right hand side still has to be evaluated fully double precision, and only when you copy back into the receiving variable, then you get the conversion to single precision. Well, that means that if you have mixed expressions or a mixed assignment, you still have to be able to reason from that using this semantics. And the same is true for procedures. You pass stuff in. If you have an array which is declared as intent in, then whatever happens inside the subroutine, it must make sure that things are not changed. Of course, you specify inside the routine intent in for this particular array. so it can't change anything there. But if you have some sneaky code which accesses the array in another way, for instance via the module in which it is originally defined, of course then the compiler can't see that. But the semantics in general is such that you should be able to reason without knowing too much about the implementation.
Okay. So copying is not necessarily required for crossing procedure boundaries.
No.
And the idea is to try and avoid it. Okay, well that actually, I think, reduces my desire for pointers, because I was going to say that for pointers that you'd only need to copy the address anyway, even if you were in a pass by value, not by reference.
Yes. Well, pointers are actually come with an array descriptor.
Yeah. So plus some metadata.
That's also.
Right.
But for pointers, it's a bit more complicated, because pointers can also allow you to specify array sections with strides. Strides other than one.
Okay.
And of course, then it gets very complicated. And then quite often copy in, copy out will occur. But that's a detail which is, well, most compilers will tell you that sort of thing are happening. But in general, it's not necessary.
Okay, so now let's talk a little bit about use cases. So the use cases for allocatables are basically, if I don't know the size of the array needed at compile time, or I don't know the specific type that I'm going to have at compile time, there's actually a lot of cases where you may not necessarily need an allocatable, at least anymore, because you can declare variables in blocks or subroutines or what have you.
Yep.
With sizes based on the inputs to that block.
That's right, yes. The automatic arrays.
And with class variables, frequently you're passing in something of a concrete type, and so you don't actually need it to be allocatable because it's coming in as an input.
Exactly, yes.
Okay.
So you've got a lot of options to work with the memory. The drawback of automatic arrays, automatic variables like that, is you can't control whether, well, if the array size becomes too large, you may end up with too much for the stack.
Right.
And that causes a core dump of the program. You have no control. So if you know that your automatic arrays might get fairly large, it's in general a better idea to use them as allocatables rather than as automatic arrays.
Okay. Just
because then you have control. Then you have control. You can allocate the array, and you can see whether that succeeded or not. With automatic arrays, you can't. Right. Quite often you have compiler options to control whether that comes from the stack or from the heap. For instance, the Intel Fortran compiler can do that, and I guess Fortran also. But that's relying on what your compiler can do, and I generally don't want to rely on that sort of things.
Right. It's effectively relying on a compiler, not a standard.
Yes. And of course, if you have a very critical program, certainly do use all the tricks the compiler can do. But it does mean that your program relies on something outside of the source code.
Right.
And whether that's acceptable is something You should decide for yourself, I think.
Mm-hmm.
What I've seen in the past is also that a real becomes a double precision, for instance, if you set the right compiler option.
Right.
Well, that's the sort of things just about everybody I know despises. And you really shouldn't allow that sort of thing to happen.
Right. Okay. So now let's move on to the use cases for pointers. So what would be a motivating use case for why you would prefer a pointer over an allocatable?
Right. With pointers, you can easily define recursive data types.
Mm-hmm.
If you think of linked lists or trees, hash tables, that sort of things, those are quite often expressed in recursive data types.
Mm-hmm.
And that's something you can do with pointers. I'm not sure whether it's allowed now with allocatables.
Mm-hmm.
I think it is, but I should check. But certainly.
I have come up with one or two implementations of a recursive data type where I used allocatable, but it's not quite as simple as with using pointers, because you need an intermediate derived type. You need an abstract type, and then you can be either the base case or the recursive case.
Yeah.
And then you can use just allocatables, but like you said, it's not quite as straightforward and simple as using the pointers.
Precisely, and in that case, you quite often want to be able to point to something else.
Mm-hmm.
If you have a circular buffer, for instance, then of course it bites itself in the tail, and that's easily done with a pointer.
Mm-hmm.
You can't do that with an allocatable.
Correct.
And the literature on this sort of things is always looking at pointers. So it's easier to use pointers in that case.
Mm-hmm.
Basically because everybody thinks of pointers then. And sometimes, like you say, the language doesn't really allow it. And it does feel a bit strange also to have a recursive data type with an allocatable inside, which is of the same type. It doesn't feel right.
Uh-huh.
So that would be a case where pointers are certainly more attractive than allocatables.
I don't know if you could have a derived type that has an allocatable component that is of the same type. But the way I've implemented it before is I have an abstract type.
Mm-hmm.
One of the extended types has a component which is class of the abstract type.
Right. So
and the other is not, right?
Yeah.
So
circular definition then.
It's not necessarily a circular definition.
No, that's right. No, it's yeah.
That breaks the circular.
Yeah.
The circular reference there.
Yeah.
But, okay. So now I do want to kind of ask the question of what was the example that you mentioned that you got a question about that had to do with the difference between allocatables and pointers?
Yes. Well, what happened was that this guy used a circular buffer. The circularity wasn't essential, but a linked list, say.
Mm-hmm.
And one implementation did work, and the other one was giving strange results, core dumps or whatever.
Mm-hmm.
And it turned out that he was using a allocatable as a local variable to allocate the memory he needed for storing in the list, and then the list was pointing to that allocated memory.
Mm-hmm.
But of course, on return from the routine, that allocated memory disappeared.
Right.
So in that case, you really need a pointer.
Right.
So you use the pointer to allocate the memory you need, and then you can give that that memory to the list, which then keeps track of it. It's just that if you use allocatables a lot, you tend to forget that this sort of things happen because they are so nice. And it took me a while to figure out what was going on there.
It's really nice to have your memory cleaned up for you, but sometimes you don't want that memory cleaned up. Yes. And then you forget.
Exactly. Yes. And I thought maybe you can solve that with a move-alloc routine, but that only works for allocatables, not for allocatables and pointers.
Right. Okay. This brings me to the question of how do you avoid memory leaks with pointers? Because at some point, somebody needs to clean up that memory. And
yes,
what are some tips or tricks that you might have for deciding when to clean up that memory?
That's a good question. I think that if you use pointers in abstract data types, like linked listed, etc., then it would be a good idea to have a finalizer for that type of data, because the finalizer can then clean up everything.
Right.
If you use pointers for work memory, then most probably you are better off with allocatables because they are cleaned up automatically.
Right.
If not, then you should be very, very careful about it. The language doesn't give you much handles to handle it in a more sophisticated way. It's just like with opening files. You have to be well, perhaps not careful, but you have to take care of them yourself, to close them when you don't need them anymore, and they might get in the way. Same for pointers. I don't know of anything which can help you with that. Other than, say, an encapsulation in a linked list of these, or something like that. So that with finalizers you can make sure that everything is cleaned up automatically. That's the basic idea of finalizers, of course.
Right. I've always been a little unclear on exactly the semantics around the finalizers, I think, because if I have a return value from a function, does the finalizer get called on the return value? Because it goes out of scope.
Yeah, I think so. I think so.
So when I return a linked list from a function, its finalizer will get called and clean up all the memory that I was trying to add back.
Oh, that's a good one. That's a good one. Gosh.
That's why I've always kind of been shy of pointers. Is like, I'd like to encapsulate this into something and have a finalizer that cleans up automatically when I'm done with it. But when I'm done with it isn't when it goes out of scope. It's when I'm done with it.
It's a good one. I expect so, because well, basically you would say you return an array, so no pointers or something, but just an array. Then the result gets copied into another array, and that original array should be cleaned up. If you have a derived type with a finalizer you return that type from a function, I'd say that something similar happens.
That's my understanding of
yes,
the way
of course, the default assignment will take care of copying all the data.
Exactly.
Now, if you would have a function returning a derived type with a finalizer, and you assign that via pointer. So the pointer, the variable, you have pointer arrow function. That's a situation where we're looking for right now.
But no, the situation I'm looking for is I'm not returning a pointer, and so I'm trying to hide away the fact that I'm using pointers, so that the users of such a facility or library don't need to know that I'm using pointers. But if my type has a finalizer, that finalizer will be called all over the place. And how do I know which time the finalizer gets called that it's supposed to actually clean up the memory?
That's a good one. I don't know. That's certainly some a use case which you should examine.
Right. So my understanding is that if you're using pointers, you really have to expose the fact that you're using pointers, and be careful about deciding who, quote unquote, owns that data, and they're responsible for cleaning it up at some point.
Yeah. And that means that you want to hide that as much as possible from the innocent user. And that's another reason for using allocatables whenever practical.
The most common example that I've seen of people doing this is you just have a type-bound procedure for whatever's hiding away the pointer, and say, when you're done with the data behind this, please call the delete function. Otherwise, there's a memory leak. Right?
Yes. Of course, the encapsulating derived type could have that finalizer. It's not a pointer, so there's no chance that you do something inadvertently. It could be a local variable of that derived type. The derived type has a finalizer, so if you return from the function or the subroutine, that finalizer gets called and everything is cleaned up. That should be certainly the way it should work. But the thing you sketched, yeah, that's something which you should investigate. I know there's have been a lot of troubles with finalizers implementing them in the compilers.
Yeah.
This could be one of the reasons.
Yeah, it's nice that there is a place to put code that you'd like to run when something goes out of scope, but going out of scope isn't always the time that you want to clean up whatever that resource was.
Exactly.
Because you may be trying to pass that resource to somebody else.
Yes. And I can imagine two different scenarios here. If your derived type contains allocatables, it will probably be okay.
Right.
Because the allocatables with the default assignment will get copied.
Right.
And certainly with the automatic reallocation, that should be okay. If it does contain pointers, then of course you do have a problem.
Right.
Because the pointers will only get the pointers on the left-hand side will only get references to whatever the pointers were referencing to.
Right.
So in that case, you get dangling pointers. And that would call for a user-defined assignment for that particular type.
Yep. Okay. Is there any other gotchas or interesting tidbits that you'd like to add?
Well, An example I use in my courses on Fortran is that pointers can point to, well, actually really weird things, array slices that go all over the place.
Mm-hmm.
I've never had use for it, but it's a nice idea that you can do that sort of thing.
Mm-hmm.
The other thing I can think of, which I have illustrated in the past, but never actually used, is vector indices. You know the concept?
Not exactly.
Right. Well, normally you have a slice from 1 to 10, say,
Mm-hmm.
but you can also specify an array of indices.
Okay.
It can be quite useful to select all the elements you want,
mm-hmm.
rather than via loop. You just specify them via the vector.
Oh.
Let me type that in the chat.
Okay. Yeah, that's a use case that I probably would have at some point, but I've never used that trick.
This, for instance.
Mm-hmm.
These are vector indices.
Right. So
and what it does is it selects elements 1, 2, 4, 10, and 3 in that order,
mm-hmm.
and puts them in the array A.
Okay.
That's something you can use,
mm-hmm.
and of course that can also be an array name rather than this constructor.
Uh-huh. Okay. Oh, there's one more thing that I kind of wanted to talk a little bit. Pointer semantics and differences from other languages.
Right. Yes.
The Fortran pointers are, in some sense, very different from C pointers.
Yeah.
And to me, the biggest difference is their kind of default behavior. Right. So in a language like C, if I have variable equals something where the variable is a pointer, that is changing where the pointer points to.
Exactly.
Whereas in Fortran, that is changing the underlying value.
Yeah.
And so that's a difference between the kind of quote default behavior.
Yes. When, as I understand it, when this was designed, they felt that copying the value was going to be more important than changing what the pointer is pointing to.
Mm-hmm.
So changing what the pointer is pointing to requires special syntax, the arrow,
mm-hmm.
Whereas changing the value in the memory it is pointing to is just the assignment.
Mm-hmm.
So it was a really deliberate decision to do it this way.
Right.
In a language like C, you always have to use the star or the ampersand to do things. And I guess that is because in C, pointers are much more important than they are in Fortran.
Right.
That's one thing. The other thing is that pointers can only point to other pointers or to variables which have the target attribute.
Right.
And a reason for that is that the compiler then can know in advance which variables will be or may be subject to this sort of operations, which makes it possible to do optimizations which are not possible in C.
Okay.
For instance, in C, you have to be aware that every variable can have an aliasing. Aliased. In Fortran, this is impossible unless you do something slightly dumb. It's impossible unless a variable has a target attribute. If that's the case, then the compiler knows it has to look out for for other things, because it may have been pointed to.
Right.
If not, then it can optimize the use of registers and that sort of things.
Mm-hmm.
And in C, that's impossible.
Okay. One thing that I do want to point out, just for in case anybody who's listening later, the target attribute does not necessarily mean that that data will live beyond the scope.
No.
Right. Just because you declare a variable and point a pointer at it doesn't mean that the underlying data will still be there when you leave scope.
Nope. Nope. There was a problem Bo ran into. I talked about.
Uh-huh. Okay. I think that was all that I had. Thanks for the discussion. This was very helpful for me at least.
Yeah, and there's an interesting problem to sort out.
Mm-hmm. All right. Well, thanks for your time, and we'll talk again later. I'm sure.
Yeah, sure. Well, let me know what you can distill from this.
Mm-hmm. We'll do. So I hope you guys found that conversation useful and enlightening. It certainly was for me. And I hope that answered most of your questions with regards to allocatable variables versus pointer variables and situations where you might want to use one over the other. Let me know down in the comments if you have any additional questions, if you'd like any other videos or explanations of different Fortran features, and make sure you hit that subscribe and the like button and click that bell icon to make sure you get notifications when we release new videos. Thanks, guys.